I showed vPointers in a previous video. I just want to drive them home a little bit further in this one, but not too much further. The vPointer is what makes polymorphism in object-oriented programming happen. If you don't have a vPointer, then when you call a virtual function, you really don't know which function to execute. Is it one for the base? Is it one for the derived? Is it one for another derived? What exactly do we need to execute? The vtable handles all that with a vPointer. You can read about it in the reading in the book. But let me just show you vPointers a little bit more. I'm going to go here and say struct base, and the only reason I'm using struct is to make everything public. Let's give this thing int member, and let's go down here, and I'm going to cout size of base. Actually, let's go lowercase here. I'm going to say base. So the size of a base, well, a base stores a single int. So really, in this case, when I say base, yes, it is a base, but it's storing an int. It's no bigger than an int. So let's run this. It's 4 bytes. Now I'm going to go in here. I'm going to add another method, void foo, or function. Sorry, it's in so many languages. One language calls them functions, another language calls them methods. C++, they are called functions. Anyway, I add a function here. It does not change the size of the base class. It's still 4 bytes because code gets put in the static storage area, the code area, the text segment of the programmers. So really, the presence of this function adds nothing to the size of the base. In fact, I can actually put some code in here just to prove it further. And I mean, it does nothing. Literally, an instance of an object is its data members and its data members alone. So bringing foo back to nothing. Watch what happens when I put virtual in here. And I did this in a previous video. What that does is it now requires the presence of a vtable. A vtable will resolve which foo should be executed when we have a pointer to a base type, which could be anything derived from base. In this example, there is nothing derived from base. But that doesn't matter. The compiler has to use some forethought and basically add this vtable. In order to have the vtable, and there's great diagrams for the vtable in the book if you go look at those. In order to have a vtable, we need a pointer to point to the vtable of an instance of this base class. So let's run this thing. Notice the size of the our base type increased by 4 bytes because we added that 4-byte virtual pointer. Now, I showed you reinterpret cast in a previous video. Let me just show you how we can use reinterpret cast to actually look at the value of the vPointer. So I'm going to say int pointer gets reinterpret cast to an int pointer the address of our base instance. Now remember, this address of base, it returns the address of a base class. I know that hopefully that's obvious, but I just want to bring that clear that it returns an address of a base, and in order to have an int pointer point to that, I have to do the reinterpret cast. So let's look at what's actually stored in that very first 4 bytes of base. I'm going to say, hey, dereference int pointer, and let's actually look at what's stored there in the first 4 bytes. Run it. We'll get some. Well, here's the size of base is 8, and then the next value is this is the address in decimal of the base type's virtual table. That's where it is actually in RAM. That's a decimal value, not a hexadecimal value, I mean. Now I'm going to go here and int pointer ++, and from the pointers video, you should remember that will move int pointer past the first 4 bytes in base. And then next thing in base should be this int member. And I believe we didn't set it to anything, so let's set it to something. Base dot int member gets 23. 23 is a unique enough number. So just to drive this home, that the first thing we're pointing at is the vtable pointer. So let's run it. We'll still get a funky address here. Now we're going to increment int pointer, and then I'm going to take this print statement, copy it. Here's a little shortcut. You can just put your cursor on that line, Control L to cut it, and then I immediately paste it. And I'll go down here and paste it again. So let's get rid of the size of here because we no longer need it. So this is the vtable address. We increment over the address of that, and then we should see Here, start int pointer should point to int member, whose value is 23. So let's run it. Boom, there you go. That is all the data in our base instance. Let me bring this back here. So here we go. Here's the vPointer pointing to this table. It's essentially a switch statement, which you'll see in a wrestle here shortly, an exercise in the assignment. It's essentially a glorified switch statement is what the vtable is. And then here's 23, the actual value of int member. So vPointers, basically the only difference between this and the previous video I did on int pointer is I actually showed you the value of the pointer. And using a reinterpret cast, I was able to grab that value.